Hello students, welcome to the third video of the module 5 joint probability distribution. In this video I am going to explain more number of problems as tutorial 1. The joint probability distribution of two discrete random variables x and y is given by f of x is equal to k times of 2x plus y, where x and y are, this is equals to k times of 2x plus y, where x and y are the integers such that x is varying between 0 to 2 and y is varying between 0 to 3. First of all, we have to find the value of the constant k and the marginal probability distribution of x and y. Show that the random variables x and y are dependent, where x is equal to 0, 1, 2, y is equal to 0, 1, 2, 3, and f of xy is equal to k times of 2x plus y. And the joint probability distribution table is formed as follows. How to get the inside values is k times of 2x plus y. When we take for J11 0 and 0, say 0 plus 0, k times of 0 plus 0, which will be 0 we have obtained here. And if we get k here, how to get k here? X value is equal to 0 and y value is equal to 1. So likewise, we will be getting the values. So these are all the values we have got here. That is 6k, 14k, 22k, 42k, and here also we have added, when we add the columns, we are getting these values. That is 6k, 9k, 12k and 15k, that is 42k. We must have the 42k is equal to 1, hence the k value is equals to 1 upon 42. And now the marginal probability distribution as follows. So for x it is 6 by 42, which is 1 by 7, and when x value is 1, 14 by 42, which is 1 by 3, and when it is 2, it is 22 by 42, it is 7 by 21. Similarly for y, when it is 0, it is 6 by 42 or 1 by 7. When y value is 1, it is 9 by 42 or 3 by 14. When y value is 2, it is 12 by 42, that is 2 by 7. And when it is 3, it is 15 by 42, that is 5 by 14. It can be easily seen that f of xi cross g of yj is not equals to jij. Hence, the random variables are dependent. Next problem. A fair coin is tossed thrice. The random variables x and y are defined as follows. X equal to 0 or 1 according as head or tail occurs on the first toss, and where y is the number of heads. Determine the distributions of x and y, and also determine the joint distributions of x and y. Obtain the expectations of x, y and xy. Also find the standard deviations of x and y. Compute the covariance and correlation of x and y. Solution. The sample space S and the association of random variables x and y is given by the following table. Here it is H. So here it is 0. X value is 0 and y value corresponding to that is 3. And here, as the y value represents the number of heads here, so this is a 1. Next, x value is 0 and y value is 2 because 2 heads are occurring. Here also x value is 0 and y value is 2, and x value is 0, y value is 1 because only one head here. And here the tail appearing here is 1. So for all these, the first appearance is tail, therefore for all of these it is 1. And the number of heads here is 2. Here the number of head is 1. Here the number of head is 1. and here there is no head, hence it is equals to 0. Then the probability distribution of x and y is as follows. X is equal to 0, 1 and y is equal to 0, 1, 2, 3. So P of x is equal to 0 is, when we take P of x is equal to 0, what do we get it? When x is equal to 0, we have P of x is equal to 0, 4 divided by 8. Out of totally 8 combinations, we have x is equal to 0 for 4 of these. Therefore, it is 4 by 8 or it is 1 by 2. Similarly, when P of x is equal to 1, when x is equal to 1, also we have 4 combinations out of 8. Hence, this is also equals to 1 upon 2. Next, P of y is equal to 0 is 1 upon 8. I'll just show you y equal to 0. P of y equal to 0, this is the only combination we have where y is equal to 0 out of 8 combinations, and therefore it is 1 upon 8. And P of y is equal to 1 means we have 1, 2, 3 out of 8, therefore 3 by 8. And for y is equal to 2, we have 2, 2, 2. 3 combinations we have, therefore here also 3 by 8. Whereas y is equal to 3, only one combination is there, therefore it is 1 upon 8. Let us see here. See, when y is equal to 1, it is 3 by 8. Y is equal to 2, also it is 3 by 8. Whereas y is equal to 3, it is 1 by 8. Thus, we have the following probability distribution of x and y as this y is equal to 0, 1 by 8. When it is 1, it is 3 by 8. When it is 2, it is 3 by 8. For 3, it is 1 by 8. Now, the joint distribution of x and y is found by computing Jii, that is Jij is equal to P of x is equal to xi and y is equal to yj, where we have x1 is equal to 0 and x2 is equal to 1, and y1 is equal to 0 and y2 is equal to 1, y3 is equal to 0, 2, and y4 is equal to 3. Now, J11, that means when x is 0 and y is 0, we don't have the such combinations, and hence it will be 0. Next, J12, that means when x is 0 and y is 1, we have only one combination, that is 1 upon 8, which corresponds to HTT. And J13 is P of x is equal to 0 and y is equal to 2. We have two combinations of that type, that is 2 by 8, and outcomes are HHT and HTH. And similarly for 1,4, that is when x is 0 and y is 3, 1 upon 8, that is only one combination, that is nothing but HHH. And for 2,1, when h is 1 and y is 0, that is 1 by 8, and the corresponding outcome is TTT. And next is 2,2, that is when x is 1 and y is also 1, we have the combination 2, that is 2 upon 8, but which combinations we have is THT and TTH. Next, when x is 1 and y is 2, that is J23, which is only for one correspondence, that is 1 by 8, the corresponding outcome is THH. And for J24, when x is 1 and y is 3, it is 0 because the outcome is impossible. So these values can be written quickly by looking at the table of S, X, Y. The required joint probability distribution of x and y is as follows. So here we have written for corresponding to 0 and 0, it is 0, 0 and 1 is 1 by 8, 0 and 2 it is 1 by 4, 0 and 3 is 1 by 8, and the total sum is equal to half. Similarly for 1 and 0, when x is 1 and y is 0, it is 1 by 8 and 1 by 4 for 1 and 1. For 1 and 2 it is 1 by 8. For 1 and 3 it is 0, and the total is half. And again the column total, if we take, it is equals to 1. And the column total individually, if we take, it is respectively 1 by 8, 3 by 8, 3 by 8 and 1 by 8, whose total again gives us equals to 1. Now let's compute the expectation of x, that is mu x. Mu x is given by summation xi into f of xi, where mu x is 0 into half plus 1 into half, which gives us half. Mu y is e of y, which is yj into g of yj under the summation, which gives us 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, which is 3 by 2. Next, e of xy, the formula is given by xi yj into jij. So, which is given by 0 plus 1 by 4 plus 2 by 8 plus 0, which is equal to half. Next, let's find out the sigma x square, which is e of x square minus mu x square, and sigma y square is e of y square minus mu y square, where sigma x square is 0 plus half minus 1 by 4, which is equal to 1 by 4. And sigma y square is given by 0 plus 3 by 2 plus 3 by 2, 3 by 8 plus 3 by 2 plus 9 by 8 minus 9 by 4, which is equal to 3 minus 9 by 4 or 3 by 4. And when we take the root of sigma x square, it is half. Root of sigma y square, if we take it, is root 3 by 2. We have got the standard deviation for x and y respectively. Now let's go for the covariance of x and y, which is e of xy minus mu x mu y, where e of xy is found to be 1 by 2 and mu x into mu y is 3 by 4, which is equal to 1 by 4. And at last, this row of correlation of xy, which is given by covariance of xy divided by standard deviations of x and y respectively. So, row of xy is given by minus 1 by 4 divided by half into root 3 by 2. This was minus 1 by 4. Minus 1 by 4 it is. So, minus 1 by 4 divided by half into root 3 by 2, which is equal to minus root 1 by root 3. Hence, the covariance is given by minus 1 by 4 and the correlation is given by minus of 1 by root 3. Thank you.